Hello. Now we are going to look at algebraic fraction addition. So how do we add fractions that involve algebra? And as with everything that we do in algebra, it links back to what we already know in number. So how would we add these two number fractions together? Well, first things first, we would look for, can we simplify the fractions that we've got? So is there a highest common factor between 5 and 7? No. Is there a highest common factor between 6 and 12? Yes, 6 is the highest common factor there. So I can simplify my second fraction here. So keep everything in context. Let me plus, take out your highest common factor of 6. And we end up with 5/7 plus 6 divided by 6. This is effectively this fraction multiplied by this. 6 all over 6 multiplied by 1 all over 2. So 6 all over 6 is 1. So 1 times a half is a half. So now we have a much nicer situation to have to deal with. Now I have, instead of denominators of 7 and 12, I have 7 and 2, which is much nicer numbers to have to work with. So now that we have done our first job of simplifying, which is always the first thing we try to do, how do we add fractions? Well, to add fractions means we're counting up how many of something we've got. Well, if I've got sevenths of something and halves of something, I can't add them up. I can't count up how many of something I've got. I need to be counting in the same units. I need to have the same denominator. So I need to have this broken up in the same number of pieces as I have this broken up into, so that I can count up how many of them I've got in total. So to do that, I have to get my lowest common denominator. So what is the lowest common denominator of 7 and 2? Well, it's just going to be 7 by 2 is 14. So now I need to get my denominator to be 14 in both cases. So what do I need to do here? Well, I need to multiply 7 by 2, but I can't just multiply numbers at random. I have to multiply above and below by 2, because that is equivalent to multiplying by 1. 2 divided by 2 is 1, just like we did for our simplification of our fraction here. So I'm not changing this fraction, I'm changing the way it looks so I can count it up more easily. What do I need to do here? I need to end up with 14, so I have to multiply by 7. And I can multiply by 7 over 7, because again, that's the equivalent of multiplying by 1. So I'm not changing my fractions, I'm changing how they look, so I can count them up more easily. So 5 by 2 is 10, all over 14, plus 7 all over 14. Now I'm counting in 14ths. I can say, how many 14ths have I got in total? So I end up with 10 plus 7 all over 14. So I end up with 17 all over 14. You could write that as a mixed fraction, but you do not have to. This is a perfectly acceptable answer unless they ask for a mixed number or mixed fraction or a decimal, in which case we would work that out on the calculator or by just writing it out for a mixed number. Now, everything we just practiced in our number fraction is exactly the same as what we're going to do in our algebraic fractions. There really isn't any difference other than we have to now use the tools of algebra that we know in combination with what we already know for number. So is there any simplification we can do for our fractions? That's the first job each time. There's no common factor there. There's no common factor there. So we're immediately looking for how are we going to add up these fractions, or in this case, take them away. So I need to be counting in 20ths. That would be my lowest common denominator in this case, and it's just multiplying the two numbers. It isn't always, but a lot of the time we just end up multiplying the denominators. So I need to multiply here by 4 all over 4, and I need to multiply by here by 5 all over 5. So when I do that, I end up with 8x all over 20 minus 5x all over 20. Now I can count up how many 20ths I've got in total. So I have 8x minus 5x. Notice I am taking away this numerator because I'm taking away the fraction. So I have 5x 20ths that I'm taking away from 8x 20ths all over 20. So I end up with 3x all over 20. There's no common factor there, so that is as far as I can go. Now if we start to have these terms here, it makes no difference to the basic structure of what we're doing, just we are going to have to do our bracket multiply when we are multiplying above and below by numbers. So what is our first job? It is to simplify. There's no common factor there, and there's no common factor there. It looks like there might be one here, but there's no common factor of 3 in the second term, so we can't take out a common factor of 3 across everything on the top line. So we have no highest common factor there other than 1. So if we can't simplify, we're looking for our lowest common denominator, which is just going to be 9. 9 is our lowest common denominator. If we went for 27, we'd just have to simplify at the end. It wouldn't cause any crisis, but we always try to look for the lowest common denominator that we can go, so we're not adding in common factors that we then have to remove later. So this is already at 9, so I could multiply by 1 over 1 if I wanted to, just for showing that I'm getting the same denominator. Here I need to multiply by 3 all over 3. So now I have 3 sitting outside a bracket, so I have 3 multiplied by each thing inside the bracket, as I have 1 multiplied by each thing inside the bracket here. So I do that multiply and I end up with 27x minus 3 all over 9, and I'm subtracting 1 by each of these, doesn't change them. That's 5x minus 3 all over 9. Now I'm counting in ninths. I can add everything up, so I have 27x minus 3. Now, this is where we come back to we were subtracting 5x here. Now we're subtracting 5x minus 3. I am subtracting all of that. Now, why is that important? Because if I subtracted the 5x, it's very easy if I don't write down this line that I could simply say I have minus 5x minus 3. But if I write this out here, I'm subtracting all of this fraction away. I'm less likely to make a sign error with this term here. And this is all over 9. We have 27x minus 3 minus 5x. If we like to think about it, we can think we're subtracting one of this fraction away, so minus 1 of this. So minus by minus is plus is the significance, all over 9. Now we can do some tidying up. We have some like terms that we can add up. So we have units here, and we have x's here. We put different symbols on them to keep track of them. So we end up with 22x minus 3 plus 3 is just 0. So we have 22x all over 9. There is no common factor there, so that is as far as we can go. And then finally we have just 3 fractions added together. It makes no difference. We follow exactly the same logic. So what's the highest common factor of 6? Sorry, first job. Is there a common factor top and bottom? No, no, no. So first job is done. Now we're looking for how do we add these up? We have to have the same denominator. So we're comparing like with like. The lowest common denominator, or lowest common multiple of 6, 3, and 5 would be 30. So we need to get 30 underneath all of these fractions. So here I need to multiply by 5 over 5 because I need to get 6 to go to 30, so I need to multiply by 5. Here I need to multiply by 10 all over 10 to get 3 to go to 30. And here I need to multiply by 6 over 6 because I need to 6 by 5 is going to give me 30. So I multiply all of that out. 5 by 4x and 5 by minus 11. So I end up with 20x minus 55 all over 30. You can actually write this out under a single fraction, so let's do that. And we have to be careful. We are subtracting, so we're multiplying by 6 here, and we are also subtracting all of this away as we're adding the 10. So we have to put stuff in brackets so we don't make this error of putting down minus 24 instead of plus 24. So when we do that, we can multiply out these brackets and then simplify. And we're going to note all of our like terms. We have x's here, and we have another x here. and we have numbers there, or units there. So we add up all of our units, add up all of our x's, because we are now comparing like with like. We've now got 30ths for everything, and we get minus 22x, and we don't end up with any common factor this time. So that is what we need for now.